John Muir Health, Walnut Creek Campus, Sterile Processing Department, Decontamination Series, Ultrasonic Cleaners, Part 1 of 2. Even though we cannot see the action happening, the ultrasonic cleaner is a mechanical cleaner. The washer disinfectors use impingement as the mechanical means of cleaning. Ultrasonic cleaners use cavitation, which we will discuss. So what happens when the lid shuts? To understand the ultrasonic cleaner, let's look at the name. What does the term ultrasonic mean? Ultra means beyond, sonic means sound. So the name implies that the cleaning is by an action that is beyond sound. To find out what this action is, we need to ask some questions. So our first question is, what is sound? Sound is produced when something vibrates. The vibrating body causes the air around it to vibrate. Vibrations in the air are called traveling longitudinal waves, which we can hear. Knowing this, we have a good idea that sound waves may be a part of the cleaning action. The second question we'll ask is, how are sound waves measured? As we have learned, sound travels in waves. There are two basic measurements of sound, frequency and amplitude. Frequency is measured in the number of sound waves per second. This measurement is called hertz. The more sound waves per second, the higher the pitch of the sound. The less sound waves per second, the lower pitch of the sound. Amplitude is how loud a sound is. This is measured in decibels. Now that we know what sound is and how it is measured, we need to ask, what is beyond the sound of humans? The range of hearing for humans starts at about 20 Hz. 35 Hz to 50 Hz is a low, deep bass note. On the high side, the highest possible frequency heard is generally 20,000 Hz. While 20 to 20,000 forms the absolute borders of human hearing range, our hearing is most sensitive in the 2,000 to 5,000 Hz frequency range. Let's test it out. The next slide will demonstrate the sound range from 20 Hz to 20,000 Hz. Your computer speakers may not be able to reduce sound until it hits about 100 to 200 Hz, so don't be alarmed if you don't hear anything until it reaches that measurement. We now know that ultrasonic means beyond sound. We know what sound is. We know how it is measured. We know what sound is beyond hearing of humans. How does this translate to instrument cleaning? Speakers were placed inside water to send sound waves through the water. One speaker is sent to 25 Hz, the other is set to 60 Hz. Look at the difference in the water's action with the 35 Hz gain from 25 to 60 Hz. The action is sharper and faster. This is how the ultrasonic cleaner works. Sound waves are sent through the water. We saw what water looks like when sound waves at 60 Hz, or 60 sound waves per second, looks like. Ultrasonic cleaners for hospitals produce 20,000 to 40,000 Hz, or sound waves per second. In this video, you will see the water is still. There is actually lots of activity happening in the water. You just can't see it. This ultrasonic cleaner is on and set at 20,000 Hz. A vial with glass beads will be placed in the water to show the sound wave activity. We saw the action of the ultrasonic sound waves in the water. When the ultrasonic waves pass through a cleaning solution, the molecules of the solution are set in a very rapid motion and small gas bubbles develop. The bubbles in a cleaning solution grow until bursting inward and dislodging soil from instruments. Look at the red arrows. This is where the energy is going, ultimately through the center of the bubble onto the flat surface. That flat surface being a surgical instrument. As the bubbles grow larger, they become unstable until they implode, not explode. Look at the examples. The bubble on the left is imploding. It's caving in on itself. The bubble on the right is exploding. Watch this video of a bubble imploding. Watch where the energy is coming from and where it is focused when the bubble caves in. This video is in extreme slow motion, also under heavy magnification. We would not be able to see this with our naked eyes. After the jackhammer effect, a vacuum forms in the solution that draws minute bits of foreign matter, including microorganisms, from cracks and crevices, such as hinges and serrations on instruments. This vacuum action results in cleaning hard-to-reach areas. We saw the imploding of a bubble in the previous video. This video has a bubble imploding against a solid. Watch the energy hit the solid, then pay close attention to the vacuum effect at the finish. In this video, we will demonstrate the cavitation process. Watch how nothing happens with the ultrasonic turned off. When the ultrasonic is turned on, watch the graphite disappear. Watch when he sandwiches the plastic together. This simulates an instrument and the tight tolerances. Watch the graphite being pulled out of this crevice. That's the jackhammer and vacuum effect. That's cavitation. I hope this presentation gave you some insight on how cavitation and the ultrasonic cleaner works. Now we know what happens when the lid shuts.